Hi, it's Mr. Bennett. In this video, what we're going to talk about is we're going to talk about the layers of the Earth. Now, I know I told you that in this unit we're going to talk about plate tectonics. So what the heck are we doing talking about the layers of the Earth? Well, you can't understand how plate tectonics work unless you understand the distinct layers of the Earth, because the reason why the plates and the continents move and everything is all described by what's going on with the major layers of the Earth. Now, you can see in this picture we got 4 layers of the Earth right here, and we will go through all of them and talk about them. So what are they? The layers of the Earth going from the outside in is we have the crust on the outside. Then the next layer we got going on is the mantle. Then we have the outer core and the inner core. So if you come down to this picture down here, here's the crust, here's the mantle, here is going to be your outer core, and then here is going to be your inner core. Those are the 4 layers of the Earth going from outside in. So the layer of the Earth that we live on is the crust. And honestly, the only layer of the Earth man has ever been on is the crust, because once you get beneath the crust, it's way too hot for us to survive. Now, why do we have 4 distinct layers of the Earth? It's because differences in temperature, pressure, and density. Okay, that's what we got going on there. Between the crust and the mantle, there are big differences in temperature, pressure, and density. Between the mantle and the outer core, and then between the outer core and the inner core, there's going to be differences in pressure, density, and temperature. Now, basically what you got going on, as you go down from the crust down to the outer core, your temperature is going to go up, your pressure is going to go up, and your density is going to go up. Okay? So the inner core is going to be the hottest, most dense, with the most pressure on it. The crust is going to be the coolest, least dense, with the least amount of pressure on it. And it's these differences in temperature, pressure, and density that affect all the different layers and make it so they show up as distinct layers. Okay, now let's go through and let's talk about each of the layers of the Earth in a little bit more detail. So first off, let's start with the crust. And the crust is the outermost layer of the Earth, and it's the layer that we know the most about because it's the layer that we live on. So what we got going on with the crust is the thinnest layer of Earth by far, and it's not even close. At the ocean, the crust is only 3 to 5 miles thick. At the continental or on land, okay, land we got going on here, the crust can be 25 miles thick. Now that may seem really thick, but the thickness of the crust is to the rest of the Earth like the thickness of the skin of an apple is to the rest of an apple. If you take an apple and cut it in half, that the layer that is the skin of the apple is going to be basically the same thickness to the apple as the crust is to the rest of the Earth. So it's a really, really thin layer compared to the rest of the Earth we got going on. Now, temperature of the crust, pretty good variation here. At the top of the crust, it's going to be whatever the air temperature is at that given time. So if the temperature outside is 70 degrees, that's the temperature of the crust at the top. When you get down to the bottom of the crust, so when we've gone down, 3 to 5 miles of the ocean or 25 miles down at the continental, the temperature rises to 1600 degrees. So at the bottom of the crust, the temperature is 1600 degrees. So really, really, really hot. This is a reason why we've never drilled all the way through the crust. Man has never left the crust because it's too hot. We tried to drill through the crust once, and we got about halfway through and it started melting all our tools because the temperature was, up there 500-600 degrees. Other thing we got going on with the crust, it is the least dense of all of Earth's layers by quite a bit. Okay, so this one weighs the least per given amount, so the lowest density of all the layers. And there are 2 main types of crust, okay? All of the Earth's crust is not the same. We have what we call oceanic crust, and this is going to be the crust that's underneath the ocean. And then we have continental crust. This is going to be the crust that we live on right now. So anywhere that's land, that's going to be continental crust. Now, the reason why we talk about this is there's differences between the 2 different types of crust. Oceanic crust is more dense, and it's made out of basalt, which is a type of cooled lava. Continental crust is less dense, and it's made mainly out of granite. So this is the reason why any place, and we'll talk about this more when we talk about plate boundaries, where a continental crust hits oceanic crust, the oceanic crust goes underneath the continental crust because it is more dense. Okay, so the 2 types of crust, you got oceanic crust and continental crust. Continental crust is thicker. Okay, that's where this 25-mile thick comes in, and it's less dense. Oceanic crust is thinner, and it is more dense. So that's the crust for you. All right, next layer as you dig towards the center of the Earth is going to be the mantle. So the mantle is going to be this layer right there. That's your mantle going on. Couple of things about the mantle. This is the thickest layer of Earth by far. It is 1,800 miles thick. Okay, so that's what I mean by the crust being by far the thinnest. The crust is 3 to 25 miles thick. The mantle is 1,800 miles thick, so considerably thicker than the crust is going to be. All right, temperature range we're talking about with the mantle. Well, the coolest part of the mantle is the part that borders the crust, and at that point, the temperature is going to be 1,600 degrees. When you get down to the very bottom of the mantle, where it touches the outer core, the temperature is going to be 4,000 degrees. And this is hot enough to melt any metal, any rock. And so as a result of this, all the rocks and all the metal in the mantle are melted and they're liquid, okay? The mantle is where your lava comes from. Lava is what comes from the mantle. And all lava is melted rock, melted metal, because the temperature there is so hot. Now, because of these differences in temperature, something in the crust unique happens in the crust, and that is called a convection current, okay? As I mentioned, at the bottom of the crust, of the mantle, the temperature is 4,000 degrees. At the top of the mantle, the temperature is 1,600 degrees. And so what happens in the mantle is the rock gets heated up, and when it gets heated up, it wants to go up, because when you heat something up, it wants to rise. This is entirely how hot air balloons work. So the parts of the mantle that are close to the core get heated up to 4,000 degrees. When they get heated up to 4,000 degrees, they rise towards the crust. When they get up to the crust, they start to cool down, and they're going to cool down to 1,600 degrees, and then they're going to sink, because when something gets cold, it sinks. It's going to come back down to the core, get reheated by the core, and it is going to rise up again. And we call this a convection current. You can see this in this animation right here. You can see the stuff getting heated up by the core and rising up, and then it comes up here and cools down, and it's going to fall back down to the core and get heated up again. Now, the reason why I'm mentioning convection currents now, we will be talking a lot about convection currents, is this is the whole reason that tectonic plates move. The movement of North America, Africa, whatever, is entirely based on these convection currents, because as they come up and spread out, that's going to make the land go this way, and it's going to make the land go that way. And that's what causes continental drift, is these convection currents. So something to remember, convection currents in the mantle are very important for understanding continental drift. Last thing about the mantle we want to hit up real quick, it is more dense than the crust, but it's less dense than the inner and outer core. So the mantle is right there in the middle. It's not the hottest, it's not the coolest, it's not the most dense, it's not the least dense. It's right there in the middle. So the mantle is your C student. It's right there in the middle. It's not an A, it's not an F, it's right there in the middle. So going even deeper, the next layer we're going to encounter is going to be the outer core. So Earth's core is made up of two layers. You got the outer core and you got the inner core, and I'll tell you the reason why we differentiate between the two. But first off, let's talk about the outer core. The outer core is roughly 1,400 miles thick, okay? So about 400 miles thinner than the mantle, so very thick layer still, but just not quite as all thick as the mantle you got going on there. Temperatures on this. At the top of the outer core, so where it's touching the mantle, we're looking at 4,000 degrees. At the bottom of the outer core, where it's touching the inner core, your temperature is going to be 9,000 degrees. And so we got a difference of almost 5,000 degrees between the top and the bottom of the outer core. Now, the main thing we got going on here in the outer core is because it is so hot, it's mainly made out of melted metals, specifically nickel and iron, okay? So up in the mantle, we have melted rock and we have melted metal. In the outer core, we basically have all melted metal. That's the only thing we find down there. And that's the big difference between the mantle and the outer core, is the outer core is far more dense, it's hotter, and you don't find any rock there. Whereas in the mantle, you find lots of melted rock, okay? Now, one thing to understand about the outer core is because of this difference of 5,000 degrees, you also have convection currents that happen in the outer core. Things heat up as they touch the outer core. They rise because they're hot. They come up and touch the mantle, cool down, and then they fall back down again or they heat up again. And so we have these movement inside the outer core. But the thing that's moving is metal. We got liquid metal that's moving. And whenever metal rubs against metal, you make a magnetic field. And this is where Earth's magnetic field is formed at. It is our liquid outer core that makes the magnetic field that we talked about in last unit that protects us from solar winds. The other thing that Earth's magnetic field does is this is the reason why your compass works. Is Earth's magnetic field all comes out of one spot, and that's the reason why all compasses work is because they point to Earth's magnetic north pole. All right? So that very important magnetic field that we talked about last unit, without it there would be no life on Earth. It is generated in the outer core because of the temperature differential causes the liquid metal in the outer core to move, and as it moves, it makes a magnetic field. So that's the outer core for you. Okay, let's talk about the last layer. At the very center of the Earth, you have what's called the inner core. Okay, so once again, we've gone from the crust, the mantle, we got the outer core, and now we're down to the inner core. So this is the very center of the Earth. How big are we talking? 800 miles thick. So 800 miles thick, and it's a perfect circle is what you're looking at. That is going to be Earth's inner core. The rest of them are also circles, but they got a core to them. The inner core is all there is. That's all we got left. Now, this is going to be your hottest layer. It's the most dense layer, and it's the layer that is under the most pressure. And if you think about it, it makes sense. The thing in the center is going to be the hottest. It's going to have the most pressure because at the inner core, you have the weight of the crust, the mantle, and the outer core all pushing down of it, okay? This is kind of like the person who's at the bottom of a pyramid or someone who's at the bottom of a doggy pile or whatever. That's the reason why the pressure is so high at the inner core, because all the other layers are pushing down on it. Temperature, what we're talking about? Ranges from 9,000 at the very outer part of the inner core where it's touching the inner core. So right here we're looking at 9,000. When you get to the inside, the temperature is 10,800 degrees. And this is hotter than the surface of the sun. Now the core is not hotter than the sun because once you get inside of the sun, we're talking millions of degrees. But the actual core is hotter than the surface of the sun itself, extremely hot. The pressure is 45 million pounds per square inch. The pressure there is so intense that if we somehow put you in the inner core, your body would be mashed down to the size of a marble because the pressure would just crush you that much. So 45 million pounds per square inch. Intense amount of pressures down there. Now the reason why that pressure is so intense is here's something about the inner core that's kind of hard to get your head around at first. The inner core is solid. It is made of solid iron. Well, wait a minute. I told you all the other layers, the outer core and the mantle, were liquid because it was so hot. So this is the hottest layer. Why is it? It's solid. And it's because the pressure is so high that that iron just can't be a liquid. So much pressure is put on that inner core that even though it is really, really, really hot, that pressure makes it a solid, and so it can't change to a liquid. So that's something that's important to know about the inner core. And this is the reason why we divide the core into two layers. We have a solid layer and we have a liquid layer. The outer core is liquid, the inner layer is solid, and so that's why we have two layers of the Earth's core. So that's the inner core for you. An 800-mile thick layer of solid iron that is really, really, really hot and under extreme pressure. The thing I want to talk about in this video is why the heck is Earth's core so hot? Why is it the center of the Earth is as hot as the surface of the sun? Well, there are two main reasons for that. First one is something that we call heat of formation. And this is where 50% of Earth's heat comes from. And what this is, real simple, is this is heat left over from when the Earth was formed. Lots of heat was made when the Earth was formed from two reasons. First off, for the first billion years the Earth was on the planet was in existence, it got the crap kicked out of it by asteroids and meteorites, just constantly pounding the living snot out of it. Every time one of these asteroids or meteorites hit the Earth, it produced a little bit of heat. That heat was absorbed by the Earth, and so there's some of the heat of the formation. Now, when that asteroid or meteorite hit, anything it had in it that was really high density would sink down through the still very hot Earth. It would sink down to where it got to the core. As it moved, that produced friction, and that friction of those metals sinking down through the mantle, through the outer core into the inner core produced heat, because anytime you rub things together, you make heat. And so the sinking of these metals through the liquid layers of the Earth produced heat. Okay? So that's where half of Earth's heat comes from, is the Earth still hasn't cooled off 4 billion years later from when it was formed. So that's half of Earth's heat. Where's the other half come from? Radioactive decay. At the center of the Earth, you have radioactive materials, things like uranium and so forth. these radioactive materials, as they decay, because remember, radioactive things are slowly changing into something else. That's what I mean by decay. As they change and decay, they give off heat. So radioactive materials in the center of the Earth are producing heat, and that's where the other half of Earth's heat comes from. Okay, so that's the two main sources of Earth's heat. You got heat of formation, heat left over from when Earth was formed, and then radioactive decay. Radioactive materials in Earth are giving off heat, and that's keeping us warm as well. All right, so that wraps up the first video on the layers of the Earth. There'll be a second one where we talk about a few more of these things. That's the one you should watch next.